Okay, the last part of our study on calculus is to do with optimization and the rate of change. By definition, optimization is the process you follow to solve practical problems using calculus. I want you to remember the following. The derivative of an expression gives the following. It gives a formula for the gradient of a tangent at any point that is on the curve. The derivative also gives the x values of the maximum or minimum points, and the derivative also gives the instantaneous rate of change for a particular value. In real life, we maximize volume, area, or profit. I think this now is very important for you to internalize into your mind. And we minimize area, cost, distance, and time. So we are going to basically look at two examples, and thereafter we will get some classwork as usual. Our first example reads, the distance fallen by a stone which has been dropped from a hot air balloon is given by S of t is equal to 4,9 t squared, where t is the time in seconds and st is the distance in meters. So part A says, determine the average speed at which the stone fell between the second and the fourth seconds, at the 7th seconds. Now, it's very important for you to realize that we are talking of average speed. And the average speed by definition is change in y over change in x. So in this case, we need s at 7 and then s at 2. And then we divide by 7 divided by 2. And that is exactly what I'm going to show you here. To get our average gradient, it's s of 7 minus s of 2 all over 7 minus 2. When simplified, you must get that. You are substituting 7 into this formula that we have already talking about. So our 7 is the time, so it's 4,9 times 7 squared, and then 4,9 times 2 squared. The difference is divided by 5 because 7 minus 2 is 5. Then when you simplify that, you get 44,1 meters per second. Remember, we are talking of gradient, and that is change in distance over change in time. That's what, by definition, that's velocity. Those of us doing physics, you can understand that readily, but even those that are not doing, I have tried to explain from the beginning, so you must also understand. Part B says, determine the velocity of the stone. Part 1, after 2 seconds. Now we are given a formula for distance because they said st is our distance. So we use our calculus and find the first derivative. So volume of velocity of stone is equal to s dash of t, which means we are deriving the distance, which means we get 9,8 t. And what is the time? The time is 2 seconds. So we substitute, we end up with 19,6 meters per second. The same applies to part 2 in part B, where we are doing the velocity at t equal to 7. Again, we substitute a 7 and we get 69,6 meters per second. Part C reads, determine the acceleration of the stone after part 1, 2 seconds, part 2, 7 seconds. So again, what is acceleration? Those of us doing physical science can readily understand. By definition, acceleration is the rate at which velocity is changing or speed is changing. So our acceleration therefore is equal to the second derivative of the test of the distance, because when we derive for the second time, that's velocity. Derive for the second time, we are getting the acceleration, which happens to be 9.8 meters per second. And then it is exactly the same for 7 seconds, because we are talking about the pull of the earth, because the stone is falling down, is being accelerated by 9.8 meters per second, which is a constant. It does not change. Last part is part D. If the stone hit the ground after 15 seconds, determine the height of the hot air balloon when the stone was dropped. So it should be a question of substituting our 15 into our formula for distance. Then we evaluate. We are going to get 1102.5 meters. And then it also says, part 2, the speed at which the stone hits the ground, the speed, which is S dash. We are right here. S dash of t, which is 9.8 t. Then our t is 15 seconds. So we substitute and we get 147 meters per second. And the last one is saying the acceleration of the stone as it hit the ground. Now acceleration, I said it does not change. It's just the second derivative. We get our A here is standing for acceleration. It's always 9.8 meters per second. Then question number 2. A company selling washing powder wants to produce boxes which hold exactly 3 liters. Very important, of the washing powder. And this by definition is volume. Each box must be twice as long as it is wide. In other words, when the length is 2x, the width must be x, because this is twice the width. Then it says, and be in the shape of a right prism. Then part A said determine the dimensions of the box in terms of x. Obviously, we can see that this is x, this is 2x by the statement there. But we need to find our h. So to find h, we need first of all to understand that 1 liter is equal to 1000 cubic centimeters. What about 3 liters? It will be 3000 cubic centimeters. So the volume will be 2x times h, which is 2x squared h, which is equal to 3000 cubic centimeters. Then our h therefore is given by that. We simplify here, we get 1500 over x squared. Therefore the dimensions are x, 2x, and 1500 over x squared. That is part A. Part B, determine the surface area of the box in